Hello. Now we will study the isobaric process. So first let's explain the isobaric process. As we already know, for any process or any gaseous process, there is one ideal gas equation which is always true. Every ideal gas equation follows this. And in this equation, there are three variables. If my system is closed, that is, one is P, second is volume, and third is temperature for closed systems. In case of isobaric process, the equation of isobaric process is P constant. Isobaric process is a process in which the pressure inside the vessel is generally constant. It does not change. All other things will be changing, but the pressure will not be changing. So P is equals to constant is the isobaric gaseous equation. If you use this equation in the ideal gas equation, one more equation you will get, and that equation is volume is proportional to temperature. So either of these two equations represent the isobaric process. Okay, well, either volume is proportional to temperature or pressure is constant. Both of these equations represent the isobaric process. So this is the analytical representation of isobaric process. Now let's write the isobaric process. Let's show the isobaric process onto a graph. If we want to go for graphical representation of isobaric process, how we will go for it? So we'll make PV graph first. So volume is onto the x-axis we are drawing, and the pressure we are drawing onto the y-axis. In case of isobaric process, since pressure remains constant, whatever is the value of volume, so isobaric process will be represented by a horizontal line onto a PV graph, where pressure will be a constant. Let's call that constant pressure as P naught. So this equation, this representation, this line will represent the isobaric process in PV graph. Let's make one more graph, that is PT graph. If I try to represent the isobaric graph onto a PT graph, equation will one more time will be a straight line, and pressure will be P naught. So a straight line onto a PT graph parallel to the temperature axis represent the isobaric process. Now let's go for third one also, which is VT. So if I draw isobaric process onto a VT curve, so if you see VT curve, we have this equation, we have to represent this equation, which is V proportional to T. So this equation will be represented by a straight line which tends to pass through the origin. This straight line will represent the isobaric process. And in this straight line will be making some angle theta, constant angle theta, at every point onto the straight line. If you calculate the value of tan theta, that will be equals to that you can calculate from dB by dt. The slope of the line will be dB by dt, and if you see the equation, that value will come out to be equals to nR upon P naught, where n is the number of moles. As you change the number of moles, the slope will keep on changing there. So these two methods, one is the analytical method and this is a graphical method to represent the isobaric process. So that's how you can represent, and you can convert these graphs also. If this kind of graph is given to you, you can convert this into this graph by converting this equation to this. From here you get this, and then you plot it here. Okay, this is the explanation. Thank you.